So our next topic is multiplying polynomials. Okay, and I'm going to show you how to do this using something called an expansion box. Okay, now when you look at a problem like this, you might look at this and think, well, isn't that just a distributive property? And yeah, it is. Okay, and when you do a problem like this, it's technically called a double distributive property, where you have to distribute the 5x and then distribute the 2 and then combine your like terms. Okay, but what I find tends to happen is that people lose things when they do that method. It's really easy to skip over something or kind of get lost in what's going on. So that's why I like these expansion boxes. I think they help you organize a little bit more. Okay, now these directions are not going to make a ton of sense until we actually look at one. So what we're going to do to start with is we're going to make a box with enough sections on each side to fit the polynomials. Okay, so when I look at this guy, right, this polynomial on the outside, there's just one term, and this one has two terms. So I want to make a box that's 1 by 2. Okay, so I'm making it so that there's one section on this side and two sections on this side. So see, 1 on this side and then 2 on this side. Okay, and then I'm just going to write these polynomials on their sides. So the 4x squared I'm going to write over here, and then I'm going to write the negative 5x and the plus 10 here. So see how each term gets kind of its own section? That's what I'm kind of looking at doing here. All right, then what we're going to do is we are going to multiply to fill the boxes. So when we're multiplying these, you're just going to multiply the stuff on the edges and write the answers inside. So I'm going to multiply 4x squared times negative 5x and write that answer in this box. So 4 times negative 5 is negative 20. X squared times x is x to the third. And then for this box, the two edges are the plus 10 and then the 4x squared. So I'm going to multiply 10 and 4x squared. So 10 times 4 is 40, x squared. All right, and then we are basically done. The next thing we're going to do is just combine any like terms that we have and rewrite our answer. And in this case, we don't have any like terms. Okay, these two are not like terms. So my answer, okay, is just going to be negative 20x cubed. And then since that's a positive, I'm going to write plus 40x squared. So you don't use this green stuff on the outside anymore. We already took care of that part when we multiplied. And that's it, we're done. Okay, so let's do that again with the next problem. So this one, this polynomial has 2 terms, and this one has 3. So I want to make a 2 by 3 box. So it's big enough to fit this. So I'm going to make my box like this. There's 2 sections on this side, and then 3 along the top. Okay, and then I'm going to write my polynomial. So the 5x and then the plus 2 goes here. And then the 6x squared plus 4x minus 4 goes there. Okay, so that's how we're setting this up. We're just writing the polynomial along the outside. All right, and now I'm going to multiply to fill each of these boxes. So this guy here, you're going to multiply these 2 edges. So 5 times 6 is 30. And x squared times x, that means you've got 3 x's, right? So x to the third. Okay, this one, I'm multiplying the green things on the edge. So 5x times 4x. 5 times 4 is 20. X times x is x squared. This one, multiplying the green stuff on the edge. So 5x times negative 4. 5 times negative 4 is negative 20. And we got that 1x. Okay, this box, green stuff on the edges, right? So the 6x squared times 2. 6 times 2 is 12. And then x squared, there's just no other x's, right? Okay, this one, multiply the green stuff on the edges. 4 times 2 is 8. And then I'm just going to attach the x. And then this guy, multiply the stuff on the edges. So negative 4 times 2 is negative 8. All right, and now what we're going to have to do is we want to combine any like terms that we have. So you want to look at all these orange things that I've written in here, and anything that's a like term needs to get combined together. A lot of times that's going to happen on your diagonals. Not always, but a lot of times. So like these two, right? These two are like terms because they're both x squareds. Okay, and then these two, they're like terms because they're both x's. And that's it. There's no other like terms. So when I write my answer, we want to go in order from biggest exponent to smallest. So I'm going to start with a 30x cubed. So actually, hang on a second. I want to switch my color. All right, so my answer, I'm starting with the 30x cubed because that's the biggest exponent. X squared to be the next biggest, and I'm just going to combine those together. So 20x squared plus 12x squared is 32x squared. Next would come the regular x's, and again, I'm going to combine these guys together. So 20 fires, 8 buckets of water, I'm going to have 12 fires left over. And then the minus 8, no like terms, so we just copy that down. And that's it, that's my answer. Okay, so the goal of the box is just to help you organize, to make sure that you get everything set up and multiplied correctly. All right, down here, this guy, so this one's a 2 by 2, right? There's 2 terms in this part and 2 terms in that part. So I'm going to set up a square, 2 by 2 square. And I'm going to write y and then plus 6 on this side and y minus 7 on that side. Okay, just like before, I'm going to multiply the green stuff on the outside to fill each box. So this one, the green stuff on the outside is just y times y. That's y squared. This one, green stuff on the outside, y times negative 7, negative 7y. This one, green stuff on the outside, 6 times y is 6y. And this one, green stuff on the outside, 6 times negative 7 is negative 42. Okay, we want to check if we have any like terms, which we do. Again, it's this diagonal right here. So a lot of times it's on diagonals that you'll have like terms. Not always, but a lot of times. All right, and then your answer, just write it in standard form. So biggest exponent is y squared. Next biggest exponent will be the regular y. So we're going to combine these two together. So 6 plus negative 7, 6 buckets of water, 7 fires. There's going to be 1 fire left over. So you can either write minus 1y or just minus y. It's the same thing. And then the minus 42. And that's it. All right, last one, 6x plus 10 squared, okay? Now remember, when we say squaring something, that means you're multiplying it by itself, right? So this is the same thing as if I had written 6x plus 10 times 6x plus 10, right? That's what squaring means. You multiply it by itself. All right, so I need a 2 by 2 box. So it's going to be a square, 2 by 2. And I'm going to write 6x plus 10 on both sides because that's what I'm multiplying by itself. Side note, that's why we call this squaring something, right? Because it's a square where each side is exactly the same, right? No joke, that's why it's called squaring. All right, so let's multiply this. So this box, 6x times 6x, 36x squared. This box, 10 times 6x, 60x. This box, 10 times 6x, that's another 60x. And this one, 10 times 10 is 100. All right, we're going to check for any like terms, which again, here's 2 on your diagonal. Happens a lot, not always, but a lot. All right, and then my final answer from biggest exponent to smallest, 36x squared. Then I'm going to combine together these two because they're like terms. So 60 plus 60 is 120. And then plus this last guy. And that's our answer. Okay? So again, there are lots of different ways that you can multiply polynomials. I like this method because I think it just helps you organize better. Okay, so you can do things like double distributive properties, but I think this is a lot easier to kind of keep track of what's going on, okay? So that is how we multiply with expansion boxes. Don't worry, we'll practice this a lot, and you're going to get really good at it.